the triangle. So remember, guys, back in secondary math 2, you were only dealing with areas of right triangles. I'm going to remind you of that. So let me just show you. Do not write this part down. The area of a right triangle's formula is 1/2 times the base times the height. However, that is not true for anything that is not a right triangle. Not a true area formula for anything that's not right. Does everybody see how this is not right? If it doesn't say it's 90 degrees, you can never assume it's 90 degrees even if it looks 90 degrees. We know for sure this is not a right triangle. So then in secondary 3, we extended our knowledge, and to find area of any triangle, including a right triangle, you use the formula area is equal to, remember this, 1/2, it looks very similar, times side 1, times side 2, so kind of like base and height, but not really, times side 1, times side 2, times by side of the angle in between. So I'm just going to say angle, and then remember it's just the angle in between those two sides. It does have to be the angle that is in between the two given sides. Okay? Does everybody understand what I'm saying? You see how 97 is between the two sides? You would need to know that angle to be able to perform the area correctly. Okay, let's do this then. Make sure your calculators are in degree mode. If you're ever calculating something with a degree, your calculator needs to be in degree mode. So we know area is equal to 1/2 times side 1. You guys start typing this in. 12 times side 2, which is 4, times by sine of the angle in between, 97. So our area is how many centimeters squared? Did anyone type it in?
I got 23.82.
You got what?
I got 23.82.
23.82. Is that what we all got?
Yeah.
Okay, 23.82. And then the units of measurement, since we did a centimeter times a centimeter, it doesn't change our answer, but our units of measurement is square centimeters. Questions on that? Okay, next problem. Solve for x. So guys, this is not a right triangle. Okay, back in secondary 2, you learned how to find missing sides of right triangles using, right triangle trigonometry and then Pythagorean theorem. This is not a right triangle. Does everybody see it? So that's why we learned the law of sines and cosines in secondary math 3. So for this one, I'm going to use the law of sines. So remember, the law of sines is sine of the angle A divided by side A will be equal to sine of angle B divided by side B. And then these ratios work for all the angles and sides. So everybody pay attention closely. Isn't 40 degrees across from 25? And isn't 55 degrees across from x? So can we use the law of sines to go ahead and do this? Yes. Okay. So we'll say sine of, let's go with sine of 55. Sine of 55 over, what's the side? X will be equal to sine of 40 over 25. Now with algebra, solving for x algebraically, so we'll get x alone. So there's many different ways to go about this algebraically. I'm going to just cross multiply. Is everybody okay with that? So I multiply both sides by 25. 25's divide out, multiply both sides by x. The x's divide out. So I have 25 sine of 55 is equal to x sine of 40. How do I get x alone in this instance? Yeah, just divide by sine of 40, right? To get x alone, divide by sine of 40. So go ahead, type that into your calculator. Make sure you do 25 times sine of 55, hit enter, divide by sine of 40. What's x? 45? Oh, sorry. 25 and then no decimal? Okay. 25, awesome. No, it can't be. 31, okay. And here's why I said it can't be. If those angles were not the same, could their sides be the same? So that was a good way to say, oh, that doesn't make sense. So you still got 31? Okay. 31. Questions? Okay. Okay, looking at this one, solve for x. Solve for x. So Looking at this one, we could not use the law of sines because we don't have another angle. If we did have another angle, like let's say I said this was 23, we could do sine of 23 over 23, right, is equal to sine of x over 25, and then it's just algebra, but we don't have that 23. So we say, okay, dang it, we can't use the law of sines, which is a lot easier than the law of cosines. However, I can use the law of cosines. So remember that the law of cosines goes like this. Side c squared is equal to a squared plus b squared minus, dang it, I want to write this all in one. I need to go below where I have some room to write. So the formula for the law of cosines is side c squared is equal to a squared plus b squared minus 2 times a times b times cosine of the angle c, or the angle that the side's across from. So remember, I didn't use A, B, and C. I just said the side that we're, like, I just said, okay, you know that these things have to match up, right? You might have a missing side or missing angle. These have to match up. And then the other sides just are the other two sides. So looking at this, are we looking for angle X? So the side across is 25. Is everybody paying attention? So the 25 has to go on the outside. Does everybody see how they go hand in hand? So we have 25 squared is equal to a squared, which just means side 1 squared, so I'll just go with 23 squared, plus 10 squared, minus 2 times side 1, this one, 23, times side B, which is 10, times cosine of angle X, right? Guys? And are we trying to get X alone? So you got to do your algebra correctly on this one. So let's just calculate this a little bit, because, I mean, I can do it without calculating any of it, just because I can do my algebra really good, but some of you won't be so successful at this. 25 squared is 625 is equal to, can't we add those up? Yeah. So 23 squared plus 10 squared is 629. And then right here we've got to be careful. There's a minus, and then these are multiplied. We've got to keep these multiplied. So we have minus, let's multiply that out. 2 times 23 times 10. 460. Are you guys following me? 460 cosine of x. So now it's getting x alone algebraically. What's our first step? Minus 629 from both sides. 625 minus 629 is negative 4. Negative 4 is equal to negative 460 cosine of angle x. So now careful, what do we do next? Good. Divide by negative 460, right? So we have 4 over 460. I'm not even going to calculate that, but it's positive now, right? Yeah. Is equal to cosine of angle x. Isn't angle x trapped inside cosine? So then at this point, when we take the cosine inverse to undo x, since it's an angle. So cosine inverse of both sides of the equation. So then cosine inverse contracts that, right? I just can't fit it over here. Cosine inverse undoes cosine x alone. Let's type it in. Cosine inverse of 4 divided by 460 is 89.5 degrees. It's been a long time since we've done law of cosine. What? 89.5 degrees? Okay. Solve for x, problem 1 on page 57. Let's do it together. On the stage review, I'm doing it with you. Solve for x, problem 1 on page 57. So looking at this, I couldn't set up the law of sines. Now here's why. We would do sine of 22 over x is equal to sine of we don't know, right? So we wouldn't be able to do the law of sines, so that's when we'd say we must be doing the law of cosines. So then we know the law of cosines. The side that's missing has to be on the outside, right, to match up with the cosine. So on the outside, wouldn't we have an x squared? So we have x squared is equal to the other side, so 16.5 squared plus the other side squared. 24 squared minus 2 times the side 1, 16.5 times side 2, which was 24, times by cosine of the angle, which was 22 degrees. Now it's just algebra solving for x, so isn't this one going to be pretty easy? Can't we just calculate all that? Let's do that. So everyone, let's practice typing it in, because typing it in is half the battle. 16.5 squared. I'm going to type it in over here. You guys type it in to practice. I usually hit enter after this, just to make sure. But you should be okay. You type in, right? So we have x squared is equal to 113.920. You would want to write down the full decimal. 3872. Did we all get that? Now our last step to get x alone is, square root that entire decimal. So just do second square root, and then do second answer. Put in that exact decimal. You don't have to type it in again. So x is 10.7, right? Is that an answer available to you on your multiple choices? Okay, sweet. Okay, any questions? Okay, just last few on circles. This isn't on your stage, but make sure you pay attention, because this is all secondary 2 stuff. My secondary 2 stuff people have the exact same stuff on their stage review. We learned this, we did a test on it. A lot of you did bad on the test, so make sure you pay attention to remember this. So it says solve for x and y. So just quickly, let's quickly get through these, guys, and then the rest of the time will be yours, but pay attention or you're not going to know how to do it. So it says solve for x and y. So remember, if you have a circle and you have a central angle, isn't a central angle starts at the center and opens up on an arc? Central angles equal their intercepted arcs. So this angle right here would equal this arc, the measure of that arc, that is, right? Now, if you have an inscribed angle, it starts on the outside of the circle and opens up. An inscribed angle is half of the amount of this arc. Did everybody hear that? Okay, so let's do this. So can we find, okay, so it says solve for x and y. So first, let's solve for x. Isn't that a central angle? So if we knew this arc, wouldn't we know that it's equal to that? Okay, so let's find that. 360 minus 150 minus 150. 60 degrees. So then what's x? 60 degrees. Now look, isn't y an inscribed angle opening up on that same arc? So y will be half that amount, right? 30 degrees. Good. Questions? Okay. Next one. Find the length of the highlighted arc. Length. Do you guys see the word length? 90% of you will get one of these on the stage on the end of level test, and it's really not that hard if you know what you're doing. Length of an arc is radius times theta. If you're dealing with central angles, look at the picture. Are we dealing with central angles? Don't we have something starting at the center of the circle opening up? Okay, we're dealing with central angles. So it's S is equal to radius times theta. This just means the arc length, the physical length, and then this is our radius, and this is our angle measurement. Now here's the thing. If we calculate it like this, we're going to get an answer. If it's in degrees, we're going to have, like, let's say it's, so let's just go through this one. Our answer is going to be in degrees. That's not okay. Like, I don't want 2,000 degrees as an answer. So I want the physical distance. So wouldn't we change from degrees to radians? By multiplying by pi over 180, right? Pi over 180, a fancy one. Everybody?
Yes.
Okay, so our radius is 3, right? What's our theta? Good. Isn't this the highlighted arc? So don't we need this angle? If this is 90, you won't need a 360 minus 90. Guys? 270 degrees. So then theta is 270 degrees. Now isn't our answer going to come out in degrees? So I'm going to just take the liberty right now to say I'm going to change to radians. So I'm going to multiply that degree by pi over 180. So let's type it into our calculator. I want the answer in terms of pi. Do not type pi into your calculator. Pi is a never-ending decimal. Therefore, you will not be able to put it back into a fraction. So type it in. 3 times 270 divided by 180. What do we get? 9 halves. So that would be 9 pi halves. So guys, the physical length of this arc is 9 pi half centimeters. Comfortable? Okay. Find the area of the circle, find the circumference. This one's easy, right? Area of the circle is what? Pi Pi r squared. If we don't know that, you should know that like 2 years ago. Area of a circle is pi r squared. So our area is pi, and then our radius is 4 squared, right? Careful, isn't that a diameter drawn? Isn't that a diameter drawn?
Yeah.
So that's 16 pi, right? So now let's find the circumference, which means the physical, so we just filled in the circle with 16 pi centimeters squared. And then now finding the circumference is finding the physical length of the arc on the outside, the full thing. So you can just use the formula as 2 pi r, right? Which is radius times theta, because isn't all the way around the circle 2 pi's in radians? Okay? So our circumference is 2 pi times 4, right? So the physical distance of the outside of the circle is 8 pi centimeters. And this is 16 pi square centimeters. Area and circumference, which means the physical distance of the full outside circle. Questions? Okay, find the area of the sector. So guys, if you know how to find the area of a circle, you know how to find the area of a sector. That just means the section of the circle, right? So, isn't it still going to be area of a circle formula pi r squared? Yeah, but now we are saying we only want the area of this section out of 360, right? Isn't that true? So that's why it's theta over 360. We only want the area of this section, but still it's pi r squared, right? Does everybody understand where this comes from? You shouldn't have to memorize anything. It should just make sense. So our area is theta, which is 120, right? Over 360. And then pi times 3 squared. Leave your answer in terms of pi. Type it in. Go. 120 times 3 squared divided by 360. You can type this in a few different ways. But do not type in pi. What do we get? Quickly.
3.
You get 3? So the area of that section is 3 pi centimeters squared. Square centimeters. It'll just say units of measurement. Because a centimeter times a centimeter is centimeter squared. We all good with that? Okay, we're almost done. That's it. Pages 56 and 57, and then skip to pages 63 through 67. So these will be on area of a triangle that's non-right, and then log sines and cosines. This will be on circles.